So we're going to look at this limiting reactant concept at the particle level. We did the nuts and bolts level in lab the other day, but now we're going to start applying it to the chemical world. And so we're going to look at it just like we looked at interpreting balanced equations at the particle level first. So again, the limiting reactant limits the amount of product that we can make in a chemical reaction, and any other reactants that are left over are what we call excess reactants. So here is the balanced equation showing us the synthesis of water. So remembering hydrogen and oxygen are both diatomic, Hofbrinkel. So 2 molecules of hydrogen plus a molecule of oxygen can make us 2 molecules of water. So now in those containers on your paper, we see the amount of particles that we have to run this reaction. And so what we want to do is we want to make as many water molecules as we can until we're forced to stop. So again, a water molecule, I've got 1 oxygen and 2 hydrogens, and they make like those Mickey Mouse looking particles. So that's 1 water molecule. And I can make another water molecule, and I'm just going to keep doing this until I run out. Now on your paper, you can't obviously move the particles, but what you want to do is you want to draw the water molecules, and as you go, cross off the reactants that you use. So there's a water molecule, etc. So do that and see how many water molecules you can make before having to stop. So hopefully you paused the video and drew those water molecules, and what you're going to see is that you should have been able to make 6 of those Mickey Mouse water molecules, and you had to stop. Why? Because we ran out of hydrogen. So when we look, the question says which reactant is the limiting reactant? Well, that would be hydrogen. Why? Because we had to stop making water because we ran out of hydrogen. It limited our production. By default then, which reactant is the excess reactant? That would be oxygen, because we still have some left. How much do we have left? How many molecules remained? The answer is 1. There's 1 molecule. Yes, there's 2 oxygen atoms there, but again, they're together, so that is 1 molecule. And as I said, we were able to make 6 of those water molecules. So that wasn't too bad because we were only making 1 product. Well, now look at the next reaction on the back. This is the complete combustion of methane. So methane reacting with oxygen, making our carbon dioxide and water. So what we have to do to complete this task is we want to draw the particles, but we have to follow the recipe. We have to use that very important mole ratio. Because every time methane reacts with oxygen, it produces 1 carbon dioxide molecule and 2 water molecules at the same time. So you can't just draw the carbon dioxides and then go and draw the waters. You have to draw 1 carbon dioxide molecule and 2 water molecules at the same time. So looking at the little pictures, carbon has the X in it, and then the hydrogens are the open circles surrounding it, and our oxygens are the closed circles. So I'd like you to pause the video and again follow the recipe: a carbon dioxide molecule and 2 water molecules until you can't do any more. Try and keep track of what you're using from the boxes and disassemble the molecules in an orderly fashion. Don't just randomly pick carbons and hydrogens. Try and break them down in a systematic fashion. So again, pause the video and try and do that and see how you do. Alright, so hopefully, you could draw 1 carbon dioxide molecule and 2 water molecules, and then you could do this again, and you could do it 1 more time. At that point, you had to stop. Why? Because we ran out of oxygen. If you, like I said, did it in a nice fashion, you should have seen that you have a little bit of the methane left. So again, which reactant is limiting? Oxygen. It ran out. We had to stop production. Which reactant is excess? You could write the CH4, or you could write methane. And then we have one molecule of that methane left. And looking at our pictures, or just knowing from our ratio, it's a 1-to-2 ratio, we were able to make 3 carbon dioxide molecules to go with the 6 molecules of water. All right, so what then if we had too many particles to count? Here's our recipe for making a molecule of glucose. When I make a molecule of glucose, I need 6 carbon atoms to go with 6 molecules of hydrogen and 3 molecules of oxygen, and I make 1 molecule of glucose. Well, here's what I have available to me. In the cupboard, I have 144 carbon atoms, 186 hydrogen molecules, and 255 oxygen molecules. So using that recipe, and using what you have available, try to work your way through and see if you can figure out the excess reactant and the limiting reactant and how much stuff is made and left. So pause the video, give it the old college try, and then I'll go through it with you. Alright, so again, the most important factor is the mole ratios. Every time I make a molecule of glucose, I use 6 carbon atoms. I have 144 available. 144 divided by 6 says that I can do that 24 times. Okay, I can take 6 carbon atoms and make a glucose molecule 24 times. With hydrogen, again, 6 hydrogen molecules each time. I have 186 available. When I divide that, it says I can do that 31 times with the amount of hydrogen I have available. Oxygen, there's 255 oxygen molecules available. I need 3 each time, so I divide by 3, and that says with that amount of oxygen, I could make 85 molecules of glucose. So, which reactant is limiting? Well, that would have to be carbon. Because if we put all of our reactants together and start the process, after 24 times, carbon is all gone. Hydrogen and oxygen are like, hey, let's keep making stuff. Carbon's like, nope, I'm out. And so it is the limiting reactant. How many molecules of glucose can we make? Well, that would be 24. Because once we make 24, production stops, and that's it. Obviously then, hydrogen and oxygen are the excess reactants. How many particles of each are left? A little trickier. So we made 24 molecules of glucose. Every time we do that, every time we make a molecule of glucose, we use 6 hydrogen molecules. So 24 times 6 is 144 molecules that we used for our hydrogen. How many did we have available? We had 186. So we used 144, so we have 42 hydrogen molecules left. Yay. What about oxygen? Well, with the oxygen, each time we made 24 glucose molecules again. Each time we use 3 oxygen molecules. So that's 72 molecules used. We had 255 to start with, so 255 minus the 72 used, we are left with 183 oxygen molecules left. And that's how you do that. This is awesome. I know you were just thinking that. So again, this is how we look at it on the particle level. We will do another activity with this. We'll do a quick check on the particle level, and then we'll move on to the mass level. See you then.